So, welcome. Thanks for coming. This is a presentation I did last year for the last year's user conference. I took the slides from then and the scripts from then, and I added a few things. But I just want to be, we're such a small group. I want to be, as interactive as possible. So, if you want to ask something specific, just go ahead, and we can try and I can try and answer your questions and show you some tricks and stuff. So, are you familiar with the information schema? Are you using it? Yeah. Okay. Okay. So. Okay. So. I don't know, what are you doing with information schema? Is there something particular you're using it for, or is it more like?
What?
Are you using information schema for something particular, or what do you use it for?
I use it for mainly like a database admin and maintenance side stuff.
Okay.
So because information schema has the metadata such as table information and data type information of the tables, and sometimes well, specifically I wrote some scripts to convert things from Latin 1 character set to UTF-8, and
right.
then I go there and grab that, and then generate scripts on the fly. Because I do not want to hard code things.
Right.
So you go there, grab things, generate on the fly, and then apply it. So that's generally the gist of it. What I'm doing, but sometimes when especially when look at the table information, such as what table do you have, it looks like it does take a long time. Sometimes it varies. Sometimes it's like that, and sometimes it takes time. And yesterday during the user camp, Mark Leaf was here, the support guy. He said, when you are doing the table stuff, basically essentially what it does is that it goes to the directory, look at the FRM files, and do a LS and DIR kind of stuff.
Yeah.
So that's why it's slow. So I guess that doesn't make sense.
Yeah.
But that's
okay.
What I'm doing. Okay.
So we heard a few things. Use it to look at metadata and to generate scripts to make your maintenance tasks easier. Yeah. So that's exactly what I used it for. Anybody else use it for other things?
Well, when I'm at a new contract place, I use it for seeing how much space their data takes up and the indexes do, because they're generally entered.
Okay.
And do a select count to see how many rows.
Right.
Production, large table. So I use the information schema. I don't think I use it enough. That's fine.
Okay. Okay.
Oh, so you can get the the storage usage information out of the data.
Oh, they have like the data length and the index length. So I compare that to see if the index is larger than the data. Then I go to that table and go, oh, how many indexes?
Yeah, that's very nice. That's very nice use.
Okay.
You can do things like this, right? So you can do like tables, schema, table name, table rows, data length, index length.
In fact, I have a sticky, and I just change the table name on the sticky so I can cut and paste and do it when I feel like a table's problematic.
I'll just get this up for you. So here you can see table rows. Can everybody see is it large enough?
Can you make it large?
I'll try. I'll do my best. So table rows tells you the number of rows that's in the table, which is not reported for InnoDB tables, but only for my items. Oh, sorry, that's I'm mistaken. You get it for every table, but it will only be accurate for my ISM tables, and we're looking at a couple of views right now, so there it's null. Data length and index length, and which you can use to estimate size. On Planet MySQL, there was this little gimmick going on, where people were using something like this to generate a Google chart of their database size. Anybody picked it up?
Yeah, I saw that blog, right? There's a
yeah.
Okay, yeah.
Yeah, so it's the same principle. You just use the you can, of course, we're looking now at individual tables, but you can roll up using the group by and sum the lengths and
Now you mentioned that this is accurate for my ISM
the
table.
table rows.
The count. Now,
How do you get it accurate for InnoDB?
There's no guarantee. You never get it accurate. Yeah.
I mean, because sometimes I do find that it fluctuates a lot.
Oh, that's what I'm gonna ask next. Is that
You can be off 100,000 rows.
Really? How large total?
Well, according to the information schema, anywhere from 205 million rows.
Okay, yeah. So you get 10%.
180.
Yeah, so it's 10% off. Yeah, yeah, that's possible.
I know it's a big table.
Yeah. Well, the reason is that the InnoDB is structured in a way that it can't really have this information, accurate at all times, unless it would actually actively maintain it a lot. And all it really does for InnoDB is it tries to get a good enough figure for the optimizer to feed to the optimizer. So that's what you see back in the table
So when
rows.
it's that off, does that mean my optimizer's not going to be working very well?
Well, it's what it tries to do is it has to do with the InnoDB statistics gathering part, and this will just try to be good enough. So I don't know enough about InnoDB performance tuning to estimate whether this is.
I mean, because if it's a million rows or 100,000 rows off,
Yeah.
I don't want that.
To happen. Yeah.
Yeah, I want to tune my optimizer then.
Yeah. Well, I think this is more of a performance issue thing, but there are probably other people that know more about how you could help to. Okay, so well, I built a few scripts over time. I wanna show you because all you guys know the information schema. I don't have to cover all this stuff, I guess. Everybody know this diagram? If you like, you can download this for free. It's available from one of my websites, and it's you can use this for whatever purpose you like. It's just an entity relationship diagram. It's a conceptual diagram of the information schema because, of course, information schema aren't really tables and there aren't really foreign keys, but these are the relationships between it. And well, you can use this if you want to build a query. You'll see how things are connected.
Where can we get that?
Give you the URL. If you just Google diagram information schema, you'll get a. Yeah, so this is already the 5.1 already. So. Let me see, can I get this? So this is the full URL. Okay. So what do I have? Okay, I have a few things we can talk about. I have a little script to find redundant indexes. I've got a little script to generate schema documentation, so that you don't have to write schema documentation stuff. And I have a script to create federated tables. and I have something to check foreign key constraints if they're off. Is there anything in particular you would like to go into and discuss in detail how you can get this information out of the information schema? I can pick one if you like.
Actually, any one of them you mentioned are interesting to me.
Okay.
I don't know. But,
Redundant indexes is called.
Redundant indexes, okay.
yeah.
Yeah, okay. Let's take redundant indexes. So what I did for redundant indexes, I did two things actually. First of all, this is one of the interesting things of the information schema, is that there is no indexes table, right? There's no indexes table in the information schema. You've got a statistics table, and this contains one row for every indexed column in your server. And this is whack. I mean, a lot of people don't know how to, don't understand this thing. And I see a lot of scripts that try to do something with indexes, and they use the statistics table, but they make the mistake of, forgetting that there's a row for every indexed column instead of every index itself. So if you want to do things with indexes and with index columns, then it's easier to first create a little view for yourself to roll up the columns and make sure you get one row for every index instead of every index column. So this view over here is exactly what it does. You just select from information schema.statistics, and we group by table schema, table name, index name, and index type. And also non-unique, because this is basically a little trick, because when we're grouping by, it will already order things, and if I just make it easier for the eye to order also on uniqueness, so I put this in there too. Okay.
Do you have this available online?
Sorry?
Do you have this available online? Or?
Yes, yes. This is actually on MySQL Forge. I will show you the link. So that is forge.mysql.org. And if you look for redundant, you will find actually a few things there which might be of use to you. So here's a redundant index finder. And this is my code. So there's all the stuff you need. It's just those two.
I only found you.
So what I do is I do it in two steps, right? I create first this little view over here to find the indexes. And I group by table schema, table name, and index name. And what I do then is I make a group concat of the column names. So I roll up the columns and make sure I get one string out of the columns over there. And this makes it easy to get a quick overview of your indexes. So if I do something like, let me see. What I do for myself is I have a little separate utility database where I put all this stuff in. So just to keep it together and to make sure it doesn't pollute the other things.
Do you need data in it? So if I'm working locally and I just have the schema node data, will it work, or do I need to have data in it?
To have data in where?
In the
Populate the schema tables that you showed in your diagram.
Yeah.
Is data needed? Probably so, right? To get some type of information.
Well, if you want to practice, of course, some data is nice. But what I do is I have some simple data. Perhaps I'm not understanding the question correctly.
So like on locally, I'll sometimes do a MySQL dump of the database without data.
Right?
And then I install that locally just to look at the schema.
Oh yes.
Do I need to populate some seed data in there?
No. When you have the structures, that's enough. Then the information schema will report it.
Okay.
Yeah. Yeah. Okay. So once we have this, we have an easy view for the indexes themselves. So redundant indexes. This is actually a concept which is I read a few blogs about people looking for redundant indexes, and if you think about it, it's actually quite complicated because anybody here can describe what a redundant index is?
Yeah, a redundant index usually you go by redundant index can be a single column index along with a composite index, as long as the composite index, the first column, is the same as the single column index. In that case, that's kind of redundant because when you're doing querying, you're looking at the first column of that composite index. So in that case, that's redundant. But obviously you have two indexes that are on the same column, then that's obviously a redundant as well.
Yeah. So what you're saying is that when you have two indexes, and the one index is a prefix of the other one, so the first few columns or the first column are actually already in the other index, but the other index is bigger, it's got more columns.
Right.
Then by definition there will be more cases where you can use the second bigger index, because it's got more columns. And the cases that you could solve with the smaller index, you can also solve with the bigger index, right? So that's a good point. Anybody else have some?
Well, there's also what I've seen with developers that are not MySQL people, that first of all, they don't understand what the primary key is, so they create a primary key or not. Lots of times they'll do a unique key, and then they create an index on the primary key or the unique key, and sometimes they'll create two just to be sure they're covered.
Right.
And I don't know what school that, one guy was from MIT, so
Okay.
he learned that at MIT,
Okay.
and so.
Well, I think I know where that comes from, because in MySQL there's a one-to-one relationship between keys and indexes, right? If you create a primary key, you're creating an index, right?
Right.
But personally, I like to keep things separate. So for me too, an index, not so necessarily MySQL, but just when I think about the index, I'm thinking of an access structure, right? Something that makes access more efficient, optimization feature, really. Whereas a primary key, it's more of a term which belongs to the modeling. When you're modeling a schema, then you create primary key, and you're doing it because it's an identifier, right? You're doing it because it's a constraint, and you want to guard some business rule, right?
Yeah.
So obviously, and that is of course the strange thing, that every major RDBMS implements constraints like this using indexes, right? So in MySQL, there's no distinction at all. If you're creating a primary key or you're creating a unique constraint, it's actually physically the same as the unique constraint, the unique index that implements it. But in other databases, it's not that case. For example, in Oracle, if you create a unique constraint, then it will actually create a separate index object, which by default has the same name, but you can actually give it another name. And you can actually remove the constraint, but keep the index. So that it depends on what database you're looking at whether this is true. But in MySQL, it's the same thing. Yeah? So if we're talking about MySQL, it's the same thing. So we talked about prefixes, and that's true. Prefixes is one thing where you can find redundant indexes, but it's only half the story, because the prefix thing only works if you're dealing with an ordered index. An ordered index is an index that well, for example, a B-tree index is a typical example of an ordered index. And it's an ordered index because it works by sorting the values, and it sorts in hierarchy. So first you get the first column sorted, and then within that bucket you get the second column ordered. That's an ordered index. And ordered indexes are especially good for range scans, right? If you find something in between two values, then this ordered index, in the case of the B tree, will be able to very efficiently go down a tree and find all the data pages. But there are other types of indexes too. If you have hash indexes, well, for most MySQL databases, it's not very interesting, because with all of normal storage engines, only the memory table supports hash indexes. But if you're dealing with MySQL cluster, NDB, that uses hash indexes a lot. And with a hash index, what happens is that you take all of the columns in the index, and it's used to get the output of a hash function, which will be used as a pointer for usually an in-memory value. So if you have a hash index and you want to look up something with a hash index, it really has to take all of the columns, otherwise it can't use the index. So the idea of a prefix only applies to ordered indexes and not for hash indexes, because if I have 3 of the available index values, 3 of the column values, but the hash index actually has 4 columns, well, you can't calculate the hash value, so the index is useless, right? So if you're, so this is one of the things. If you're looking for redundant indexes, it's not enough to just look at the columns. You also have to look at the index type, because if you have a B-tree index with a couple of columns and a hash index with a couple of columns, then if the hash index is a prefix of the B-tree, then it's not necessarily redundant, because it's different. So you have to keep it apart. There's another thing too why it's a good idea to keep it apart. That's because the types of queries that you can solve with a hash index are very different from the ones you can solve with a B-tree. I just said, the range scan is very good with a ordered index, with a B-tree index, but not so much for a hash index. If I have an in-between case, well, the hash index can do nothing. It can just scan the tail, and that's all you can do. So hash indexes are especially good for single key lookups. That's what they're good for. So you have to distinguish by type if you want to look for redundant indexes. And there's another thing that is important to keep in mind, and that's unicity. If you have a B-tree index that's not unique, and it has like 6 columns, and you have a smaller index which is a prefix of the B-tree, which is unique, well then obviously the unique one is not redundant, because if you would throw it away, you would mess up your schema. So this script here takes that into account. It looks at the index type, and it looks at the unicity. And what we do here is basically we take the two indexes views we just did, and we join it by table schema, table name, and index type. Because we want to compare all the indexes on the same table with a different name, of course, right? Because we don't want to, obviously, when we have an index A and we compare it with the same index A, it's going to be redundant to itself, right? That doesn't make sense. So we have to exclude it from comparing it to itself. And now we get this weird thing over here. This is basically the heart of finding the redundant indexes, because what we're doing here is we're trying to find a rule to compare the columns of the different indexes so that we can say whether it's redundant or not. So we begin here and we say, if the columns of our two indexes are the same, and they're not unique, right? So both indexes are not unique, then obviously we're going to say that these are redundant, because we've got two indexes, they've got the same column layout, both of them. The other part of the join already took care of the fact that they're of the same type. So we've got two indexes of the same type with the identical column makeup. So this is easy. This must be redundant, right? One of them is useless. We don't need one of them. And this rule here applies equally to hash indexes and B-tree indexes, because if we're looking at identical column makeup, well, then both for hash indexes as for B-tree indexes, it's by definition the same thing. And this is not the case when we're looking at the other type. So what remains is this: if we're dealing with a B-tree index, and this rule here, this part here, this actually looks for a prefix, right? If we're saying that if the column layout of the one index appears in the column layout of the other one, so if the string comparison turns out to be 1, then we know that in this case the L index is a prefix of the other one. And if it is a B-tree, then we know that it must be redundant, because we have an index which has a smaller layout than the other one. And we have to add the express rule that the smaller of the indexes is not unique, because if the smaller of the two indexes is unique, we would be throwing away business logic if we would be throwing away this index. If you think long and hard about these rules, then you will find that every single case is covered here. Well, I'm leaving out one thing. I'm leaving out full text indexes. This thing does not properly check for full text indexes. That means what I mean is, if you have two full text indexes, this script is not checking whether that is redundant, but it will keep the types apart. So for most cases, this will be a redundant index finder. And of course, you can find the source on Forge. If you find some bug, just shoot me an email and I'll try to fix it.
Now, is full text index information stored in that place? If it's full text index.
Yes,
it is stored there. Okay. Okay. In the same in that information schema view table.
Yes, if you have full text index,
okay.
yes, it will be there.
You have record there. Okay.
Yeah. Yeah. So just look at index type, and
Okay.
you will find the data there. Just let me get up the statistics table. Yeah, it's a table catalog, which is useless because it's null all the way everywhere.
Right.
Table schema is the database name. Table name is the table, obviously. Non-unique. This is going to be a 1 or a 0. So a 1 will say that's non-unique. It's always a because it's a double negation.
Why is it a big int?
Big int. Yes, I was going to say.
Well, this has to do with this. You could probably fix this in the information schema code,
Right.
but it doesn't really matter a whole lot because this data here is and in runtime the data type system used by MySQL is different from the data type system used in column declarations. So if you're defining data types for your tables and you're minding to use tiny int instead of big int to ensure that it's as small as possible, that's a storage thing really. In memory and in computation, especially in computation, these values are all unpacked and packed to a larger type. So it really doesn't matter that much that it's big int here. But I agree, it would be more logical to have a tiny int one.
Yeah.
Well, it's just that programmers look at the schema.
Yeah.
Yeah.
And then they say,
Yeah,
oh,
that's
well,
true.
that's how I get a 1 or 0. I use a big int with a
Right,
display of
that's
1.
true. Yeah, that's true.
So y'all make it harder for us that
Yeah,
come in and
it's
have
true.
to say to developers, well, I don't know why it's
I
there
agree.
like that.
Agree.
Yeah.
You want to see how this is built? How this is created?
Yeah, that'd be interesting. But another question kind of related
Okay.
to that is this: is that information schema? In the case of my understanding could be wrong. In the case of SQL Server or Oracle, actually, in a lot of cases, information schema it has no meat in it. It's just a metadata. So in other words, when you're looking at this information, it has no physical storage.
True.
So you just you essentially when you're looking at something up, you're looking at the aggregation of things on the fly.
True, that's true.
Now is that the case in MySQL? That's
Well, in Oracle it's a little bit different, right? Because in
Right.
Oracle you have the sys schema,
Sys schema, yeah.
and there you have physical tables, base tables, that
Right.
actually store,
Store data.
yeah. And you have the sys views, which are used to do metadata querying.
Right.
Those are actually views on top of these base tables, so that's a different architecture. In Microsoft SQL Server, you see the same thing. You see the sys columns, sys tables, and those are actually physical base tables which contain
Right.
So in MySQL is different because in MySQL does not have a table-based data dictionary, right? But what it has, some people say information schema is the data dictionary, but I disagree because this is more of a interface to look at it, right? It's a way to look at it. The actual metadata, if you're looking for where it's stored, well, it's stored in the FRM files. That's where it's stored.
Oh, okay.
And in MySQL, what happens is that the information schema tables are just a table, like interface to look at this metadata. And what happens is that when you're doing a query on this, I can show you how this works. Yesterday I did a tutorial on MySQL plugins, and we showed how you can create an information schema table yourself to, for example, to report the contents of the query cache. And this is something, you know, if we have some time at the end of the session, I can show you how that works. So maybe you want to see it right now. That's okay. I'm just going to crank up the virtual machine to show you how that works, and then we'll continue with the rest. And if the virtual machine is up, I'll show you how that works. So I'll just. Okay, so redundant indexes, right? Anybody, anything else more about indexes, redundant indexes? Okay. So let me really quickly tell you something about, you know, federated tables. Anybody interested in that? I have a procedure to make it easier to create federated tables, because, you know, if you create a federated table, anybody using federated tables? No, okay.
How stable are they?
Yeah, well, it works if you just want to, you know, dump a lot of data from one side to the other, and it works really well for that. If you just want to get all of it, you know. If you want to do things like you have 5 or 6 instances of MySQL, and you want to have one instance where you have federated tables, and you want to make, you know, really nice reports, and you want to have very specific conditions on, that is not going to work very well, because the optimizer and the way the federated table is implemented is just not very clever. You know, it just most of the time will just try and get all of the data from the other side.
So is it good for having multi-master, like for data warehousing?
Well, I used it to do migration, and indeed, if you have to load up the data warehouse and you need to grab most of the data anyway, then it can work pretty well. That said, I would rather take a separate tool for that stuff. Yeah, so because federated table is nice, it's a nice hack, but it's not very flexible. So if you really want to do that, if you really want to load a data warehouse, I would use other tools. Yeah. Okay, so, but I'll just quickly show how this works. So we have a procedure to create federated tables, and what it works is this, right? So suppose you have an application, you have a federated table, then, you know, in the local application schema we have a federated table, which is a little peephole to, you know, the physical table in the other side, right? So what you could do is you can here locally you can create the DDL for information schema tables, right? Because the information schema is itself in the information schema. You can create the definition of any information schema table, because you can do a query on the information schema to query about the information schema to create the table definition of some information schema table. So you can locally on your own system create a table definition for the tables table or for the columns table, right? And you can locally create physical, you know, physical table with a layout of an information schema table. And the fun thing is, this means you can actually in your local system create a federated table of the information schema at the other side. You see what I'm getting at?
Yeah.
So what I did here in this slide, you can see that we use the local information schema to obtain a definition of information schema tables, and we're making federated information schema tables to look at the information schema at another database. Right? So now we can, once we have this, we can use this information schema, which is, you know, looking at the remote metadata, to generate a table definition, and we can create this table in our local system, use the federated storage engine, and point to the remote table. Right, so this is a process where we first create locally tables with the same layout as the information schema tables which we need to generate the actual DDL for the federated table, and we point it to the other side to obtain information of the layout of a table on the other side, which we then again use to create new DDL for this federated table. And this is a fun procedure, which it's up in the Forge. You can look how it works. I've got it here. You can I think it's a pretty nice example of how you can use information schema to do stuff, and it has some nice tricks for dealing with stored procedures too. So it's more of a gimmick. It's not something that's completely really useful, but it's nice to play around with this thing. You could probably create it in a couple of smaller procedures, to make it more maintainable. But I thought it was nice to just have one script and one procedure, so that you don't have a lot of stuff to worry about. You can look this up, and if you have any questions, just shoot me an email and I'll talk to you. Okay, let's see how VirtualBox is doing. Yeah, okay, so we've got our instance here. Okay. So, this is what we created yesterday. We've got 3 information schema plugins. MySQL Hello, which is like the most basic information schema plugin you can create. MySQL Cached Queries, which reports the contents of the query cache, and MySQL user-defined variables, which reports the current, the variables which are available in the current session, which can be very useful if you're creating, if you're using user-defined variables and you want to debug it. It's very hard to figure out what variables are defined in. And the way you created this is actually very, it's not too hard. If you need a little bit of programming skills, but you don't need to be a C++ guru. It's not that hard. So let me just show how it works.
So you have to do it in C?
Yeah, C++, but it's not that hard. It's really, let me walk you through it real quick. So let's just look at the simplest example. Hello world example. So so if you're creating an information schema plugin, there's really only 2 things you have to worry about. You have to create a column layout for your information schema table. And this is what it looks like for this particular table. So this is just a C data structure. And most of the stuff here, it looks really scary, but it's really not. I've written an article about it, and you can read, for every single part, you can read what's happening there. It's I'll just.
Where's the article?
Sorry?
What did you search on to get an article on?
I'll just do information schema plugin. Let's see. So that's the first one. Oh, that's the source actually, but this article is what I meant. Best kept secret is an article, and you get a. Well, this is like a really, step-by-step wind down of what you need to do to make it work, what you need to do to make it compile. And the materials for the tutorial I did yesterday will be available on the already website after the conference too. And if you have any trouble with the stuff, just email me or Sergey, with whom I did the presentation, and you can ask us about it. So let me walk you through it real quick. What you do is you create a column layout for your table, and what we see here is this is an array. An array of st field info objects. And st field info object is actually basically it's a column in an information schema table. And here you see two entries between the curly brackets. And the first entry is actually our column. So our column is called hello, and it's got a data length of 64 characters because it's a string type. And there's some other flags which are not really interesting. And the second entry in this array is basically there just to demarcate the end of the array, because C is a really low-level language and it doesn't really understand, the concept of the end of something. So what they did is they just created a convention that whenever we put an object with a null instead of the column name, then this is the end of the array, right? So we're just creating a single column table. And if you look at the SQL side, then the thing looks like this. So, so this table definition over here is actually this thing over here.
And the not null is one of those zeros?
Yes, very good. I think it's this one. And what you can do there is you can add a bit mask of flags to tell whether it's nullable and whether it's unsigned or not. And I can show you an example of that just in just a bit.
And is there also a mask for primary key or no?
No,
There's
no.
primary.
Now you cannot define a primary key in information schema table. It really is an in-memory representation. So that's I guess very important to see that information schema tables don't have anything to do with base tables at all. Yeah, they're in-memory structures and they're just used to represent data from inside the server as if it's a table, right? So this is the first thing you need to do for an information schema plugin. You need to set up your column layout. The second thing you need to do is you need to write a function that will fill the table with rows. This example is very simple. It's a hello world example. So what we do is this thing gets called by the server. So your function gets called by the server whenever somebody is querying your table. So whenever I type in /* from information schema.mysql_hello, then my plugin gets called and the server will call this function to let it know that this table must fill itself, right? And this function is going to do it. And the server passes me a few things. It passes this thing, the THD. The THD is a thread descriptor, and basically this is the memory, the pointer to internal data structure which contains all the information about the current session. And it also hands you the second argument, which is a tables list. And this is a little bit confusing because it's a list of tables, but you need to grab the first one because the first one in this list is the information schema table that this plugin is implementing. The third argument is a condition, and basically this is the where clause that was used on your query, and you can use this to kind of implement push down condition because normally, and I never use this thing. So what happens is that you and this also explains why information schema tables have very poor performance, because the server calls the tables fill themselves completely, right? So they fill themselves completely, and any filtering and any where clauses are applied afterwards, right? So if you're querying the tables table, even if you're joining the tables table with the tables table, it's going to fill it twice and then filter it afterwards.
The information showed on information schema.tables, is it the very same method used to show table status?
It didn't used to be, but it is now.
Well, I realized that the skewed values that should have mentioned earlier on in the BD estimates are actually pretty much the same kind of problems.
It's the same, but
It's the
yeah,
same method.
it's the same thing, yes. I can show you how it works. Let me finish this thing, and we can maybe, if I have some time left, show you how it works in the real thing. So this is our fill function, and what we're doing here is very simple. We grab, the first table from the table list argument passed to us by the server, and this first thing is our information schema table. And then what we do is we have one column in this table. We know, right, because we just defined it. So here we're saying, from this table, take the first field, well, first column actually, but it's it's denoted with field. So this thing here, the 0 index, well, that's basically the first column. And then we say to this field, go and please store string value into this column. And the string value is what we defined here. So, and then afterwards, when we've filled this field, this column, we're saying that, okay, we're ready now. Now please go and store whatever is in the whatever we just written, and store it as a row in the table. And then we just end right here. So we're just writing one row in this fill function. And if we're doing like select star from MySQL hello, so this is what it does, just one row. So this is a not so typical example, of course, because normally you would want to have some kind of loop, to loop over a series of rows and fill that in your table. So if we quickly look at the query, I think the query cache is the easiest example to understand.
You also have that up at Forge?
Sorry?
Do you also have that up online? Or?
I have it online, but I don't think at the Forge. I will check this in a second. It would be a good idea actually if I could put it there. So what we do here is, again, we have an information schema table. So we define an array of the STA field info objects. And this is a little bit more interesting because we're creating a little bit more columns. And we're not just defining string columns, but we're also defining integer columns, type long. And actually, I bet you that it's going to be a big int as well. So let's just see. Show create table I think it's called cache queries. Now let me see. Show plugins.
I found an article you wrote.
I wrote 2 articles. One about the hello world,
This one?
and the second one about save points, reporting save points. And at some point I released this cache queries thing too, but I didn't write an article about it because I didn't have time to do that. So show create table MySQL cached queries. Yeah. So okay. So actually, this MySQL type long is what boils down to an int column. And you can see here that the value I used here, the 21, this corresponds to this 21 over here, this display length. And the 64 over here, that corresponds to the 64 over here. So this is the first thing. And the fill function here is a little bit more interesting than what we saw in the hello world example. Because what we're doing now is, you're just going to have to trust me on this, that this is just some code to access the query cache. And the query cache is, it's available as a global variable inside the server code, and it has a member, which is a hash table of all the cached queries. And you can read the entries from the hash table and use that in the fill function to create rows in the information schema table. So what we do here is we have this little piece of code over here, which just says, for every entry in this query cache entries, please, go and do the loop. And we grab from the query cache the blocks, the blocks that are used to store the result set, and we get the key value. So in the query cache, uses the SQL statement text of the query, together with stuff like the current database name, current character set name, and it packs that together and makes a key out of that, and it stores the result set as a blob of bytes, basically. And what this code does is it gets the blocks, and it counts the number of bytes in the blocks, and it sums them together. And we use that to fill, the columns in our information schema table. So this is a little loop to go through all the blocks of the result set and count the number of bytes in there. And finally, we store the row. And if we see it in action, we get something like, right now, it's probably empty. So. Okay, but I have a little table in the test, so if I do something like select star from test.t, and now suddenly our query cache table is filled. We got data in there. So now we can see that we have one statement in the query cache, select star from t, and it's occupying one block in the query cache. The block size is 512 bytes. It's using just 115, which means they're wasting 400 bytes of query cache for this one query. And we can do, second query. So now we have two queries, query cache. And we're wasting even more bytes because we have such small results.
How do you, go ahead.
No, go.
I'm curious to see, because yesterday when we were doing the hacking my camp, we did something similar. Now I'm curious to know, how do you hook that up into MySQL binary? I mean, when you need to make and build, how do you hook that in?
Well, firstly, it's very easy. In this case, it's really very easy because I just do this.
And it has to be in 5.1, it doesn't work in 5.0.
True.
Okay.
Well, you can do it in 5.0, but then you have to compile the entire server.
Oh, so, okay.
And do you find that you're using this so that you can better use query cache, like set your minimum block size so you're truly, where your site's using it, the type of queries, you need a different size?
Actually, no, I'm not using it for real. I just hacked it up just for fun.
Well, I guess, sorry, I guess it can be used to have a better understanding of internal, I guess that's probably would be the main purpose. And then
For me it was.
Right.
But I released the code hoping that somebody would pick it up just to try and see if it was useful for them. It seemed like a useful thing it seemed like a useful enough thing to try and to do.
Right.
I never really used it myself, but then again, I'm not a DBA, and I'm not maintaining large scale,
Because the query cache can be very, very helpful, or it can just be
completely
not
useless.
helpful.
Yeah.
And to know what's in it, and granted it's been a long time since I did Oracle, but at least you can tell what queries are
Yes.
in things. With the query cache, it just feels like this black box, and you're never quite sure, is the big beefy query I want to be query cached being query cached or not? And is turning it off better even though it's not completely off? I mean, the query cache is a big pain if it doesn't work well.
Well, you could use this stuff to see, if it's filled up right or if it's doing what you expect. Another thing that you might discover when you're doing it, I have to knock it off because the next speaker is going to. I'll just finish this one thing. Another thing you might find out when you're doing this stuff is that you might find that seemingly the same query is being cached all over. And this is because the query cache stores the binary result, right? So if the client uses another character set for connection, right, then the result set will not be the same.
Right, even if the query has one extra space in it, right?
Yeah,
something
yeah.
like that,
Or
right?
it's
Or if the-
lowercase, uppercase, so
Yeah,
we're done.
and it's even worse than that. If the client, if you have two clients from a different version,
Right.
right, then the server just thinks, you know, I can't guarantee it's going to be the same result.
Well, but you know, most of us are on the web.
Sure.
And so you have an app, and the app always has
Sure.
that.
But you could have an environment where the one server uses the old, you know, lit MySQL, and the other uses a newer version, you know, and that
Yeah.
could be, you know.
Yeah, because that's your,
Well, those are going to cause a lot of extra queries being cached for no reason.
the query cache I'm finding in the bigger houses is just a bang. It doesn't, you know, at first when you first start out, it just works great.
Mhm.
But as the app gets bigger and your data set gets larger,
That doesn't, yeah, it doesn't use it. Yeah.
Now, one other thing is that obviously you have those code there. Now, you did uninstall. So to make this plugin work, you write those C code, you compile them, and then you grab the binary, and somehow you register that binary
Yes.
into MySQL. So in other words, you don't compile MySQL binary
Yes.
with this built in, but you add this
Yes.
to the existing MySQL binary.
Yeah, exactly.
Okay, got it. That's what I want.
There are a few snacks with it, but basically that's it. You do not have to recompile your production server to install this query.
Okay, got it.
But there are a few other things you will have to do, and those are all described in the article. I can tell you, more about it if you
Okay.
like.
Okay.
And the presentations for the plugin tutorial I did yesterday with Sergey will be up on the O'Reilly website after the conference.
Okay.
So you can use that material too to learn more about this feature.
Okay, great.
So thank you all. I'm
Thank
gonna
you.
go to.
Thank you.